All right, so today we are doing different of square method. How can we do this one right here? So we will start out with this introduction to help you understand this method by first simplifying. By using distribute property to simplify the expression, we're going to do the rainbow. So x times x give you x squared. X times plus 5 give you plus 5x. We're done with multiply them. I'm going to go in on with the second one. Negative 5 times x, negative 5x. Negative 5 times positive 5 give me negative 25. Combine like term, as you can see, we don't have anything the same with x squared, so I bring it down. 5x minus 5x, ooh, it's gone. So it's cancel out, boom. So giving us with negative 25. Lovely, right? We're going to do exactly the same thing with the next one right here. So now I'm going to have a times a apple. No, it's a square. 8 times negative 7 is going to give you negative 7a. When we're done with that, we're going to move on with the next one. 7 times a gives you plus 7a. 7 times negative 7 giving you negative 49. Okay. We're going to combine like term again, as you can see. So my a squared doesn't have anything in common, so it's just a squared. Negative 7a plus 7a, what happened? It's gone. Cancel out again. Something happened. And then negative 49 is by itself. As you can see right here, there is a pattern that you keep seeing right here that happen over and over. The middle item keep getting canceled. And then we always end up with an x squared or an a squared or whatever with a power 2 in that number. Now, without doing this, I'm just going to go ahead and look at them and I can see, look at the pattern. The number are the same, but the sign is opposite. The number is the same, 5, 5, the sign is opposite. 7, 7, opposite sign. Doesn't matter what sign you go for, but the sign is always opposite. The answer always end up with a like a times a, x times x, x squared. So why don't I try? It's going to be y times y, going to be y squared. It's always going to be a subtraction as you see because positive 8 times positive 7 times negative 7 give you negative 49. Negative 5 times positive 5, a negative times a positive give you a negative answer. So negative 1 times positive 1, negative 1. Okay. So here we go. Without even trying doing the middle part right here, I can already try the conclusion. So now today our goal is doing the opposite. So we start from here to going back here to prove it to you how it works. Just like you start from here, going here, okay? So let's moving on with the lesson with me. It's a really, really easy one. You got this. All right, guys, so today we do a factoring methods called different of square. But before we doing that factoring methods right here, we want to understand the word perfect square. Now, you hear x square, right? Have you ever wondered where the word square come from? So it's just from geometry. Look about the square shape. If I have the square right here and the side that says 7, to find the area of the square, you're going to do 7 times 7. It's going to give you 7 square. And because of that, they take the shape. So that's why they say square. That's something for you if you're interested in it. But the main part I would like to talk about is 7 square going to give you 49. What could be another number like that? 5 squares is going to give you 25. 4 squares is going to give you 16. So we call all of this is a perfect square for a reason. First, it makes a square, if you can see, and all the sides are the same, so they're perfectly equal. So in order for us to identify a perfect square, you look at the number. For example, 100 is a perfect square of 10 times 10. 25 is a perfect square of two same number, 5 times 5. 36, 6 times 6. So what giving you a square, if you're going to draw them out, is a square 6 by 6. If you draw them out, 5 by 5. If you draw them out, 10 by 10. But if you have, for example, like 12, it's not a perfect square because a factor of 12 is going to give you, for example, 3 and 4. It doesn't give you a square, it's going to give you a rectangle, 3 and 4. So all you have to do is look for a number, but they are a product. Product is when you multiply of two same number, okay? So here's a table right here will help you if you would like to memorize a perfect square number of this 1, 4, 9, 16, 20, 36, 40, 9, 64, all just go on and go on and go on. So those are the perfect square. Knowing your perfect square will help you extremely with this assignment right here. And also, not only number, if you have, for example, x squared, we also have perfect square because x squared is x times x. Or it could be any variable, a squared is a times a. Okay, all of that will be a perfect square as well. Now let's go ahead and go straight to today's lesson and see how can we factor them using this difference of square method. Okay, so let's break it down with the term right here. Whenever you hear about the word different, in your mind, what kinds of operation do we do? Different means subtract. Okay, so in order for us to use this method, this is a couple of things that you gotta make sure you always have to be identified. They're always gonna be a subtract. So for example, I'm gonna give you the very, very basic one right here. It have to be a power 2. You see, do you notice the power 2? Check. It have to be a perfect square. So what number is a perfect square right here? 25. Check. And it have to have a subtraction sign. Why? Because we find the difference. Check. And it also a binomial because how many terms we have? 1 and 2. So all of this is the key feature in order for you to identify if this is a perfect square or not, okay? Or the method is different of square. So how can we do this? So let's give it a try right here. I was starting out with this question. I would like to break it down. First thing first, we check, do they have anything in common? X squared and 81, nothing in common, so no GCS, we don't check in. Are they a binomial? Yes, they have two terms, 1, 2. Okay, are they a perfect square? Yes, 81 is a perfect number that's gonna make 2 9s and 9. Do they have a power 2? Yes. Okay, here we go. As long as you have all this condition, then you are good to go. So, but this is x squared, so you also want to break it down to x and x. Okay. Do they have a subtraction sign? Yes, because we are find the difference. So what you're going to do is we can use the perfect square, but to break it down just like what we just did with the FOIL. So here we go. We have two parentheses. What come first, go first. I always think about the sentence that first come, first serve. You see, I see X come first, right? Then I will put X right here. And then over here, what comes second, we're gonna put it on the second spot. So this is second, and that's gonna be 9 and 9. The signs is always going to be opposite, so minus and plus. Or plus and minus, doesn't matter. And boom, we are done. Just like that, okay? Let's give it another try to the next question. See if we can also do the same pattern, all right? So here we go. Question option number 2. I would like for you to try first. So pause the video right here and try it yourself. Okay, here I'm back. So let's do it. 25 minus a squared. Let's double check. Do they have any GCF? No, nothing in common. 25 number, letter, nothing in common. Are they a binomial? Yes, they have two terms. 1, 2. Are they a perfect square? Yes. What go to 25? 5 and 5. All right, do they have a power 2? Yes, okay, so let's break it down. A and A. Do they have a subtraction sign? Yes, okay. Those are the things that help you identify a perfect square method. So that is a yes. All right, we always break it down to parentheses, boom, boom, first come, first serve. What comes first right here? You see 5 come first, then you have to put the 5 first, all right? And 5. What comes second? A, right, because it comes second. Then you put A and A. The size is always opposite, just like we did with the previous introduction. So that's going to be minus and plus, or plus and minus, doesn't matter. Okay, here we go. And we are done at simple at that. The same drill, okay? Do the GCF, do they have anything in common? Let's check. Well, look at the number, A and 2. They do have something in common, that's it, 2. So you want to factor them out, okay? So we'll take the GCF right here, see actually 2. So we will take the 2 outside, and I'm going to do the parenthesis. A divided by 2 give you 4, and then we got the x squared, so 4x squared. Negative 2 divided by 2 going to give you negative 1, okay? So here we go. So we're done with the GCF. All you need to do right now is just look at the inside the parenthesis to see if there's anything we can do. Are they a binomial? 1, 2, check. Are they a perfect square? Yes, number 4 is perfect. Or what go to 4 perfectly. That's it, 2 and 2, same number, but go to 1 perfectly. It's 1 and 1. Oh, do they have a power 2? Yes. That's the x squared, so that's going to be x and x. Do they have a subtraction sign? Yes, lovely. So your job now is do the first come first serve. Okay, so I have two parentheses. What comes first is that on this side, as you can see, this comes first, right? But this time it's not just x, not just 2, it's both of them, so 2x. What comes second? Okay, I'm going to take a look at this one. So what comes second is a number. So we have 1 and 1. The sides are way opposite. Boom and boom. All right, save the best for last. So we have this one right here. Let's do number 4. Do they have a GCF? Yes, they do. Let's double check. Always look at the number 4. They'll go into 100. So that's going to be a common factor right here. So we take the 4 outside. And if you start with a negative, what does Ms. Tran say? Always vent it out, right? Always take the negative outside, vent. Let it go. Let go all the negatives. So take the negative outside. So I'm going to do a parenthesis. Negative 4 divided by negative 4 is gone. It's going to give me with x squared left. So that's going to be x squared plus 100 divided by negative 4. A negative divided by a positive. I mean, a positive divided by a negative going to give you a negative. So negative 25. Okay. Oh, wow. So that's it for GCF. So let's check for the inside. Are they a binomial, two term? Yes. Are they a perfect square? Yes. That's a number, 5 and 5. Do they have power 2? Yes. So that's going to be x and x. Do they have a subtraction sign in here? Yes. Perfect. So two parentheses, first come, first serve. What come first? What come first right here? Either x's, right? Come first. So let's take the first stop. So x, x. What comes second? That's the number. So 5 and 5. The sign gonna be minus and plus. Okay, and don't forget there's a negative 4, so you put it right there. And I like to box my answer, and I'm done. Okay, easy. I know you can do it. I believe in you. All right.